Today I would like to present the study of evaluation of the effect of road structures at the boundary between sidewalks and roadways on pedestrian initiation of road crossing behavior. So firstly, I would like to start from the background objective of this study. Roads have traffic functions such as serving as a traffic zone for vehicles, pedestrians, and bicycles, access to and from roadside facilities and buildings. Toriumi et al. 2020 organized the functions of roads as shown in the following figure. Among them, in the classifications of relatively low-speed areas such as DU and EU, pedestrians and vehicles share the space together. Therefore, appropriate management is necessary. This study focused on road structures such as crossing barriers and plants as one of the factors that affect pedestrian crossing. And the purpose of this study is to propose an appropriate method for managing pedestrian crossing behavior while ensuring the necessary roadside entry and exit functions, and to analyze how road structures at the boundary of pedestrian and vehicle paths affect pedestrian crossing initiation behavior. And secondly, I would like to introduce the pedestrian application of pedestrian behavior model, which is called social force model, SFM. SFM assumes a virtual force called social force, SF, that applies the theory of forces between pedestrians or between pedestrians and barriers. Here we define segment as the place where the structure changes at the boundary of the pedestrian roads. And based on this definition, the probability that a crossing action is initiated from each segment expressed by equation 1. And the first term is called the gravitation between the virtual gravitation between all these. The second term is the degree of psychological barriers for each structure type T. And thirdly, case study in Moriyama Ward, Nagoya City. Observations were carried out from November 2021 to January 2022, and we observed 225 crossing pedestrians and recorded the segment of origin O and destination D. The crossing start and end segment of each crossing pedestrian are on this targeted road. As a result, 93 crossing behaviors of 7 ODs are shown in Table 1 was applied as the input data. In addition, the tabs T of segments that pedestrian may start crossing are defined as shown in Table 2. From Figure 1, for the other segment types except the segment type T equals to flat V, the proposed model fits well. So the choice behavior is made as to which segment of each segment the pedestrian start to cross. From Figure 2, we can see that pedestrian crossing initiation behavior is difficult to occur at T equals to step, and the tab which pedestrian crossing initiation behavior occurs the easiest is T equals to flat. There is a difference in the likelihood of crossing initiation behavior between each segment type. The likelihood of crossing initiation behavior is not represented by 0 or 1, but rather a probability according to the road structure type. And as a result, it was found that pedestrian crossing initiation behavior occurs easily in flat and slope structures. Pedestrian crossing initiation behavior can be suppressed to some extent by structures at the boundary of the roadway, such as steps and ramps, even if they are not structures that physically inhibit crossing behavior completely. And based on this, it is possible to manage pedestrian crossing behavior in areas where fences cannot be installed to ensure roadside accessibility. Furthermore, we highlighted the importance of road space design with pedestrian crossing behavior. And in this research, since the observation target points and observation data are limited, it is necessary to acquire a large number of data at various observation points and verify the applicability of the analysis results. That's all. Thank you for listening.